We're working through our exponent rules, and the first one we see is e to the negative 9, e to the 12. Remember that when you're multiplying like bases, you can add the exponent, so this is going to be e to the negative 9 plus 12, which is e to the power of 3. On number 2, we see two different things going on. We have coefficients and we have variables. So I'm going to deal with the coefficients first and then go into the variables. 25 divided by 35 reduces to 5 over 7. And then our variables, we're going to be able, just like when we have like bases, we can add exponents. We have like bases when we divide, we can subtract exponents. So this is the e to the 2 minus 7. All over, this will be e to the negative 5. So when we have a negative exponent in the numerator, we can simplify that by putting the negative exponent into the denominator. So this will be 5 divided by 7, and on that denominator, it will say e to the power of 5. Like that. On to number 3. We're going to take our coefficients and our variables separately. So you're going to have 2 to the first e to the negative 3x raised to the power of 5 times 2 times e to the x plus 1. So this 5 is a power of a power, which means we can multiply these exponents. So 2 to the 5th e to the negative 15x times 2 to the first e to the x plus 1. Just like in our last example, we're going to take coefficients first, and then we're going to simplify the variables. So using our coefficients first, we have 2 to the 5th times 2 to the first. Just like this one, we can add our exponents. So this will be 2 to the 6th. Then we're going to have e, negative 15x plus x is negative 14x plus 1. And remember, this right here is a negative exponent, so we can push that down to the denominator. But in general, we can leave this simplified 64 e to the negative 14x plus 1. Like that. On our very last one, we're going to change the fourth roots into a fractional exponent. So 6e to the 24x raised to the 1/4 power. And just like in the other examples here, we're going to take a power to a power. So this is actually 16 to the power of 1 times e to the power of 24x, which means this will be 16 to the 1/4 power, e to the 24x divided by 4. When we simplify this, 2 times 2 is 8. 8 times 2 is 16. So we can get away with this being 2, because 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. 24 divided by 4 is 6. So this would be our final answer. All right, so the very last ones, they ask us to tell if the function is just a growth or a decay, and then we need to graph the function. All right, one of the easier things for me to think about here is when I have a negative exponent, it would be something like this when I simplify it, so that if x gets bigger as it goes to 1, 2, maybe 2,000, maybe 3 million. This denominator is going to get big, 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 and the numerator is going to stay the same. So if your denominator keeps increasing as your numerator stays the same, then we know that this will be a decay function. That is an exponential decay function, and it's different from our exponential growth function. We're going to see that in number 6. As x goes in for maybe 1 or 1,000 or 1 million, as x gets bigger and bigger and bigger, this number will also get bigger and bigger and bigger. So this is going to be exponential growth. The same logic will apply here as x is 1,000 or x is 1,000,000. As we get a bigger and bigger x here, this number will increase in size, and we're going to multiply it by 5. So this number will only grow for us. Again, this is going to be exponential growth. Now let's take a look at our last one. We have 0.8 8/10 divided by e to the negative 3x. 8/10 divided by e to the negative 3x will turn positive when you push it into the denominator. So as x increases from 1 to 100, maybe even 1,000 or 1,000,000, as x gets bigger and bigger and bigger, this numerator will stay the same, and my denominator will continue growing larger and larger and larger. So again, this will be decay, exponential decay. Alright, so on the back they ask us for identifying the functions, domain, and range. So we look at y equals e to the x minus 4. We're going to use a graphing calculator to help us get our table of values. And basically what I'm looking for on my table of values is for where x or y is undefined for the function, because that will tell me my asymptote, and then I can graph my function. So when we get to where y is negative 4, x is undefined. And so that helps us with our domain and range, as well as our graph. But our domain, we can see, is going to be all real numbers, and the range is where y has to be bigger than negative 4. Because all of my x's at negative 4 are undefined. So we cannot actually be at y of negative 4, we can be higher than that. Alright, so over here, we're going to have an undefined region. When x is undefined, y is 0. And again, this just helps me with my domain and range. The domain's all real numbers, and my range is y has to be bigger than my asymptote, my limit. On number 11, when y is 5, x is undefined. So my domain is all real numbers, and my range is where y is less than 5. And you need to be careful about this one, because when you look at it on the graph, it's going the opposite direction, and that's because of this negative sign right here. It's a reflection. So y has to be smaller than 5, and usually, because of the way our domains and ranges are working out, it's been greater than. So watch out for that. Negative sign is going to flip this range here. Alright. Now let's take a look at 7.3 and our practice at 7.3. 7.3 is asking us to write out the equation into exponential form. So this is saying that 0 is the exponent of 9 to get 1. 0 is the exponent of 9 to get 1. Let's think about what that says, and then let's write it out in exponential form. So 0 is the exponent of 9. So I'm going to put my 9 down, make 0 to be my exponent to get 1. And I'm just going to make sure that that statement is true. 9 to the 0 power is 1. This is true. Anything to the 0 power is 1. And this over here will be 3 is the exponent of 6 to get 216. So let's think about what that says. 3 is the exponent of 6. So 3 is the exponent of 6 to get 216. Think about, is that true? Yes, absolutely. 6 to the third power is 216 over here. And you can start to see the pattern. We take the base, and the base here, we add in the exponents, put in an equal sign, and then our log. So here the same pattern will apply. Log base 2, so our base is going to be 2. Our exponent will be -2, and it equals 1/4. And let's think about that. We're going to take the negative, so we're going to have something like this. Now it's simplified, and 2 squared is 4, so this is going to be 1/4. That's exactly right. So this works out. So again, on this, to write it out, you would say -2 is the exponent of 2 to get 1/4 of that. All right. Let's see. Number 4, it asks us to rewrite the equation in logarithmic form. So we can just take what we did and work backwards. On this one, it says specifically, right, 9 to the 0 equals 1. So we need to kind of follow that same pattern. 0 is the exponent of 9. So -2 is the exponent of 13 to get 1/169. So again, over here, we're going to have -2 is the exponent of, means log. -2 is the exponent of, and then our base will be 13 to get 1/169. Done. Let's try again over here. So 3/2 is the exponent of 4 to get 8. 3/2 is the exponent of 4 to get 8. So let's write that out using this log here. 3/2 is the exponent of 4 to get 8. All right. The very last one says 1/2 is the exponent of 81 to get 9. So 1/2 is the exponent of 81 to get 9. And you could say 1/2 equals log in base 81 of 9. 1/2 is log base 81 of 9. All right. Now we get to evaluate the algorithm, and this is all about us typing into the calculator to make sure that we're able to use our technology instead of having to use a log table to determine the values here. So when we put this into the calculator, we should be getting responses back that look something like this. Make sure that yours matched up as well. On the next one, they ask you again, evaluate the logarithm using a calculator. So we're going to do the same thing. On this one, if we wanted to go no calculator route, this would say, right, because we don't know what that is, x is the exponent of 3 to get 81. So x is the exponent of 3 to get 81. And I would have to say that 3 times 3 is 9, and 9 times 3 is 81. So 3 to the power of 3 is 81, so x equals 3. And that's how I'm getting these responses without any calculator. Yeah, this is a good one too, right? Like, x is the exponent of 10 to get 1. So x is the exponent of 10 to get 1. And we know that anything to the 0 power will just be 1. So that's why x equals 0. And that's what you see here. Again, it should come out that way on your calculator. You want to do both. You're going to be asked to be doing both, especially on this when it comes to the STAR test and our final exam here. If they ask you to evaluate the logarithm, you should be able to do it in your head with these whole numbers. When they tell you to use a calculator, you should just be able to type it in. Remember, log has a standard base of 10. You have 10 fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We group everything in our counting in groups of 10, and that's why we're going to use a standard base of 10 here, if they happen to leave it off. But when you see the ln, again, that is your reminder that we're in log in base e. This would be something that you would use, of course, when you use financial calculations, interest, compound, continuous compound interest, and that kind of good stuff. Alrighty, simplifying the expression is a matter of us being able to take a log out. And we're going to work on this the next time that we get together. By taking the log of both sides. Okay. We need to rewrite the equation in exponential form for our homework. So this means that 3 squared equals 9. In other words, 3 as our base, log in base 3 of 9 equals 2. 3 to the power of 2 is 9. 25 to the power of 1 is 25. 2 to the power of 5 is 32. And 1/8 to the power of -1 is 8. Using our method from the class, we can say this is 2 is the exponent of 3 to get 9. 2 is the exponent of 3 to get 9. Is how you would write this out verbally. When you go to use your verbal translation, you just say that 2 is the exponent of 3. So 2 is the exponent of 3 to get 9. Again, once we get a lot more practice with this, we're going to be able to go straight from logs into exponential form and back and forth. That's the whole goal here, is we want to get enough practice to be able to do this. So you can see 3 squared equals 9, come right across. You're going to see a for number 1, 25 for a, for number 2 as well, and so on and so forth. Now let's write this into logarithm form. So use the same template that you see up here, down here. 2 is the exponent of 7 to get 49. 2 is the exponent of 7. So let's write this out how we see it. 2, the is the equal sign. The exponent of is log. Our base is 7 to get 49. So that's our actual log. 7 squared equals 49. That makes sense, and this is also true as well. So now we have all of the expressions the way they should be, and we can see a pattern emerging. We're going to take the exponent, put it on the other side of the equal sign. Your base will stay the base, and then this is the actual log. So over here, your exponent goes on the other side of the equal sign. Then we can write log. Your base stays the base, and the 1/3 is your log. Down here, again, your exponent is on the other side of the equal sign. Log stays log. Your base stays your base. And then here's your actual function. On the other side, -3 equals log base 7 of 1 over 343. When you go to evaluate this, you're going to do it on the calculator, and that will tell you this exact amount. We already know what it is. It's -3. Evaluating the logarithm here means that sometimes we could be using a calculator, but for the most part, we can do this in our head. Remember, what's over here is an unknown now. So what this is saying is 2 to which power equals 64? 2 to which power equals 64? This means that x is, right? So if we think about 2 squared, 2 cubed, 2 to the 4th, when we get to 2 to the 6th, we can see that that's going to be 32 times 2 is 64, which is going to be the correct power. So x equals 6 here. 2 to the 6th power is 64. Log in base 9 of 81. Remember to just put your unknown off to the side to clear up any confusion that may be remaining in how you're going to solve the log. From here, we can see that 9 to the x power is 81. 9 to the x power is 81. So x should, mentally here, we can see that it's going to equal 2 because 9 squared is 81. And so on. We're going to solve out that puzzle. The very last thing that I asked you to do is for your take-home exit ticket to finish that up using what we worked on in class as all part of this packet. This is all due the next time that we see each other. Thanks so much for watching, and we'll see you next time.